Hello everyone. Tests like t-test, chi-square test, f-test will come across with this terminology, degrees of freedom. What exactly degrees of freedom is, we'll understand. Formal definition is degrees of freedom are the number of values in a calculation that we can vary. To understand this, let us understand this example. Suppose that we know the mean means average of a certain data is 25 and the values are known to be 20, 10, 50, but one unknown value which we are considering it as x. In which case we can determine that x is equal to 20. How? Let us write it here. Average, that is mean, is given as 25. And since it is average, numerator will be sum of all the values, which is 20 plus 10 plus 50 plus x divided by number of values. There are 4 values. So by cross multiplication, I can say it is 100 is equal to, if I add this 20, 10, 50, it is 80 plus x, which means x is 20. That is what is specified here. Suppose that we know the mean of the data is 25. Again, mean is 25. With values 20 and 10. And then 2 unknown values. We are considering those unknown values as x and y. So here, again, 4 values. So again, this will become 100 is equal to 30 plus x plus y. Or we can say 70 equal to x plus y. Or we can also say y is 70 minus x. So one particular value, if I substitute for x, I will get some value of y. Suppose, for example, if I substitute 10, then I will get the y value as 60. Suppose if I substitute x as negative 10, then what will happen? Y will become 80. So in this case, we wrote here 70 minus x. So once we choose a value for x, the value of y is determined. Means I can vary only the value of x. I cannot vary the value of y. Or alternatively, I can express the other way also. X is equal to 70 minus y. In that case, if I vary y, I can only vary y. X cannot be varied. So since only one value can be varied, we say this particular data has got a 1 degree of freedom. Now, coming to, based on the definition, 1 degree of freedom. Why? Because only one value can be varied. If the number of observations or the sample size is 100, and if the mean of this sample is 20, but do not know the values of any of the data, means what? X bar is 20, and there are 100 observations. So I will say x1, x2, and so on up to x99, x100. How many observations? There are 100 observations. So if I cross multiply, I will have 2000 is equal to x1 plus x2 plus and so on, x99 plus x100. I can vary all these 99 values, any of the 99 values, but one value I cannot vary, it will automatically get calculated. That is what is written here. Sum x is 20 into 100, that is what written here. It is 2000. Once we have 99 elements in the data set, the last one can be determined. So here we say the degrees of freedom is 99. So in general, if the sample size of the given sample is n, then the degrees of freedom will be n minus 1. In the case of contingency table will be like a matrix having some rows and columns with some observations in that. Like this, maybe. Let me say, I'll draw 3 rows and let's say 4 columns. And here we have row totals. Let us say this is row 1, row 2, row 3. This is column 1, column 2, column 3, column 4. This is column total. So the first one will be actually sum of these rows. Let us say this is x11, x12, x13, x14. So this is actually x1j. Likewise, I can write here x21, x23, I'm sorry, x331, x31. This is actually summation xi1. So here I is varying, j is constant. Here j is varying, I is constant. This is basically a grand total. This we call, such table we call it as a contingency table. There, how do you calculate the degrees of freedom? If the order of the contingency table is R by C, R denotes rows, C denotes columns. In that case, degrees of freedom. For this example, the degrees of freedom will be, how many rows are there? There are 3 rows. So we say 3 minus 1 multiplied by how many columns are there? 4 columns minus 1. So this is 2 multiplied by 3. So you have 6 degrees of freedom. In this particular example, we have 6 degrees of freedom. So likewise, we calculate degrees of freedom in case if we come across with some contingency table. So in case if you find the contents of these videos to be useful, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you. Take care.